Dear students, welcome to my classroom. In this class of chapter sets, we are going to learn about finite and infinite sets and also cardinal number of sets. Okay, let's see what is finite set and what is infinite set. A set is said to be finite if it can be find that both starting and ending elements in the set, that is, the elements of the finite set is countable. If we can found both starting and ending elements, then only it is said to be finite, and the number of elements in finite set is countable, and we can express the number of elements in finite set. Let us see some examples. R is equal to set of natural numbers less than 100, and in this set we have the natural numbers from 1 to 99, because here we have natural numbers less than 100, and we know that natural numbers are starts from 1, and here we have the numbers less than 100, that is the last number is 99, and we can say that there are 99 numbers, 99 elements in the set R, so that the given set is a finite set, because we can find the both the first element and the last element. First element is 1 and the last element is 99. So as we can find both the first and last elements in this set is a finite set. And let us see one more. A is equal to set of whole numbers between 5 and 45. So the whole numbers between 5 and 45 are, first one is 6 and last one is 44, isn't it? So 6, 7, 8, 9 up to 44. That is, we can count the number of elements in this set. So the set is finite set. Okay. M is set of all persons in India. So it is also a countable set, because so there is a limited number of persons live in India, so that we can find the number of all persons in India, so that the set M is equal to M is a finite set. Okay. Now S is set of all students in a class. So it is also a finite set, because the number of students in a class is limited, and we can also find the number of all elements in this set. So the set S is a finite set. Okay, let us see what is infinite set. A set is said to be infinite if it is not possible to find either starting or ending or both the elements. That is, the elements of the infinite set is uncountable. We cannot count. So we cannot express the number of elements in infinite set. Okay. So for example, we have R is equal to set of all natural numbers. So set of all natural numbers means the first one is we have 1, after that 2, after that 3, and what is the last natural number? We cannot say, isn't it? Because natural numbers are infinite. So as the last element of this set cannot be found, so the set R is an infinite set. Okay, and take one more. A is equal to set of all multiples of 15. So first multiple of 15 is 15, 15 ones are 15, and after that 15 to the 30, after that 45, after that 60, but that is by adding 15 to each one, we get the next one. So we cannot decide the last multiple of 15. That is, they are endless. So the set A is infinite set. M is equal to set of all straight lines passing through a point. So through a given point we can draw infinite of lines, isn't it? If a point is given, we can draw infinitely many lines. So set of all straight lines passing through a point is also an infinite set. So S is equal to set of all integers less than 3. So the integer less than 3 is, first one is 2, after that, before that 1, before that 0, before that minus 1, before that minus 2, before that minus 3, like that. There is no starting element, as the last element is 2, because the last integer below 3 is 2, and there is no starting element for this set because they are endless. So the set of all integers less than 3 is also an infinite set. Okay, so we can say set of all natural numbers, set of all whole numbers, set of all real numbers, set of all rational numbers. All these are infinite sets because they are endless. Okay, what about null set? Is null set is a finite or infinite? What do you think so? Null set is a finite set because we know the number of elements in null set is 0. That is countable. So null set is a finite set. Null set is a finite set. Okay. Let's take next one, cardinal number of sets. So cardinal number of a finite set. The number of elements in a set is called the cardinal number of the set. It's very simple. Number of elements in a set is called the cardinal number of the set. That is, if in a set 3 elements are present, then the cardinal number of the set is 3. If in a set 10 elements are present, then the cardinal number of the set is 10, like that. And we denote the cardinal number of a set by n of a. The cardinal number of set A is denoted by n of a. So observe here, n of a, like that. For example, R is equal to set of A, B, C, D. Set of elements A, B, C, D. So that we can write, as there are 4 elements in the set R, we can write n of R is equal to 4. Number of n of R is nothing but number of elements in set R. And A is set of vowels in English alphabet. So we know that there is 5 vowels in English alphabet, so that now n of A is equal to 5. M is equal to set of letters of the word may. And clearly we have 3 letters in this word, so n of M is equal to 3. S is equal to set of 1, 2, 3, 4 up to 98, 99. That is from 1 to 99, totally 99 elements are present in set S. So n of S is equal to 99. And similarly, number of elements in null set is 0. So that cardinal number of null set is 0. That is n of y is equal to 0. Okay. So let's solve some problems under the title do this. First one. Which of the following are empty sets? Justify your answer. Set of integers which lie between 2 and 3. So is it an empty set or non-empty set? That we have to write, and we have to justify our answer also. So there is no integer exist between 2 and 3, isn't it? The integer after 2 is 3 and the integer of before 3 is 2. That is, there is no integer lies between 2 and 3. So the given set is an empty set because there is no integer exists between 2 and 3. Take second one. Set of natural numbers that are smaller than 1. So you know that small natural numbers are starts from 1 and there is no smaller number than 1 in natural numbers. So the given set is an empty set because there is no natural number smaller than 1. Set of odd numbers that leave remainder 0 when divided by 2. And we know that if we divide an odd number by 2, then the remainder must be 1. Isn't it? If we divide 3 by 2, then the remainder is 1. If we divide 5 by 2, the remainder is 1. If we divide 11 by 2, the remainder is 1. That is, if we divide any number by any odd number by 2, then the remainder is 1. So the set of odd numbers that leave remainder 0 when divided by 2 is an empty set. Okay. So because there is no odd number which leaves remainder 0 when divided by 2. Take the next one. State which of the following sets are finite and which are infinite. Give reasons for your answer. First one, A is equal to x such that x belongs to n and x less than 100. So it is clearly a finite set because in this set natural numbers are exist which are less than 100. That is a 1 to 99. So clearly it's a finite set because the number of elements in given set is countable. B is equal to x that x belongs to n and x less than or equal to 5. It is also clearly finite set because there exists only 4 elements. 5 elements. X less than or equal to 5. 1, 2, 3, 4 and 5. So the number of elements in this set is countable. So that because the number of elements in given set is countable, given set is finite set. C is equal to 1 square, 2 square, 3 square and so on. That is, there is no end element. Therefore, the given set is an infinite set. Given set is an infinite set because there is no end element present in the set. Take fourth one. D is equal to 1, 2, 3, 4. Clearly, set is finite because there are 4 elements present in the set. That is, number of elements is countable. Fifth one. X such that x is a day of the week. And we know that there are 7 days in a week. Sunday to Saturday. So that is, it is countable. So the set of given set is a finite set because the number of elements in given set is countable. Okay. Now take the next one. Tick the set which is infinite. Option A, the set of whole numbers less than 10. Option B, the set of prime numbers less than 10. The set of integers less than 10. The set of factors of 10. Now take the first one. The set of whole numbers less than 10. And we know that whole number starts from 0. And the set of whole numbers less than 10 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That which is countable. So the option A is a finite set. And the second one, the set of prime numbers less than 10. And we know that the set of prime numbers less than 10 contains the elements 2, 3, 5, 7. That is simply we have 4 elements which is countable. So the set is a finite set. Option C, the set of integers less than 10. So in the set of integers less than 10 we have negative integers which are endless. Negative integers, 0 and positive integers. So positive integers are limited, that is from 1 to 9 and 0, and negative integers are endless. So that is, there is no first element in this set. There is no starting element in this set. So the set is infinite. So we can tick this one and take fourth one. D, the set of factors of 10. And the factors of 10 are 1, 2, 5 and 10. So simply we have 4 elements which are countable. So the set is a finite set. Okay. Now we have try this. Some problems under try this. Which of the following sets are empty sets? Justify your answer. First one. X such that A is equal to set of x such that x square equal to 4 and 3x is equal to 9. We have to observe this word and carefully. So now we have to write the elements which satisfies both the equations because here it is given and. So we have to write the value of x such that x square is equal to 4 and 3x is equal to 9. If x square is equal to 4, we know that x is equal to clearly plus or minus 2. And if 3x is equal to 10, x is equal to clearly 3. So if x is equal to 3, then x square equal to 4 will not be satisfied. And if x is equal to plus or minus 2, then 3x is equal to 9 will not be satisfied. Isn't it? So the value of there is no value for x which satisfies both the equations. So the given set is an empty set because there is no possible solution for x satisfying both the equations. And take the second one. The set of all triangles in a plane having the sum of their three angles less than 180 degrees. So we know that in any triangle, in any type of triangle, the sum of three angles is equal to 180 degrees. So given set is an empty set because there is no triangle exists that the sum of its three angles is less than 180 degrees. So the given set is an empty set. Okay. Now let's solve the exercise 2.4. The first one. State which of the following sets are empty and which are not. First one. The set of lines passing through a given point. We already seen as example this one. So we can draw infinitely many lines through a given point. So the set is an empty set. Sorry, non-empty set because we can draw so many lines through a given point. So it is a non-empty set. Second one, the set of odd natural numbers divisible by 2. So odd natural numbers are not divisible by 2 because if odd natural numbers are divided by 2, we get the remainder as 1. So they are not divisible by 2. So this is an empty set because no odd natural numbers exist such that divisible by 2. X such that x is a natural number, x less than 5 and x less than 7. So if x less than 5, then it won't be greater than 7. Take 1, 2, 3, 4. They are less than 5, but they won't be greater than 7. And if we take the elements which are greater than 7, they won't be less than 5. That is, there are no natural numbers satisfying both the inequalities. So it is an empty set. It is an empty set. Fourth one, x such that x is a common point to any two parallel lines. So we know that parallel lines do not intersect each other, so that there is no common point for parallel lines. So the given set is empty set. Fifth one, set of even prime numbers. So we have a even number which is prime number, that is 2. So the set is non-empty set because there is an element present in this set. Next one. So in next problem, state whether the following sets are finite or infinite. First one, the set of months in a year. So clearly we have 12 months in a year which is countable. So the set is a finite set. Okay. Second one, set of 1, 2, 3 up to 100. It is also clearly a finite set because it has first element as well as last element. So it is a finite set. Third one, the set of prime numbers smaller than 9. So clearly we have 25 prime numbers which are smaller than 9, isn't it? The prime numbers from 1 to 100 are, number of prime numbers between 1 to 100 are 25. So 99 is a composite number, 100 is also composite number. So the prime numbers which are less than 99 are 25. So this set is also a finite set. Take the fourth one, the set of lines that can be drawn parallel to the x-axis. So in coordinate plane we can draw infinitely many lines which are parallel to x-axis. So the set of lines which can be drawn parallel to the x-axis is an infinite set, because we can draw infinitely many lines to which are parallel to x-axis, on upside of x-axis and downside of x-axis. The set of numbers which are multiples of 5. So here also multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40. That is endless. So it is also an infinite set. Next one, the set of circles passing through the origin 0, 0. So in coordinate plane through the point 0, 0, that is origin, we can draw infinitely many circles. Okay, so it is also an infinite set. So in that way we determine that whether the given set is finite or infinite. So that is the end of exercise 2.4, as well as that is the end of chapter sets. So sets chapter is very easy to solve. So in the exam point of view, it is very scoring topic. So please practice thoroughly and gain as more as possible marks. And we shall meet with new chapter in next class. Until then, see you. Bye.